All right, so we are going to finish up section 1.4 today. This is part 3, and it's called solve equations by factoring. So we know how to solve equations, we know how to factor, so this shouldn't be an issue, right? All right, so it's just putting stuff together that we have done in the past. So let's just start with an example. They don't give you any like warm up or anything. They don't explain anything to you. They just give you the problem and they want you to factor it. So this is example 7. All right, and it says to solve. So here it is. X to the 4th equals 4x squared. All right, let's take a look at it. We got to get x by itself. That's what we're trying to do. So what do you think? A lot of people might do this. Now watch. A lot of people might look at this and say, oh, let's divide by an x squared, divide by an x squared. So at least gets rid of an x squared. But what you don't want to do is you don't want to divide by what you're trying to solve for. Everybody hear that? Okay, you don't want to eliminate or cancel out what you're trying to actually solve for. So I would never divide by an x squared if I'm trying to solve for x. You with me on that? Same thing if it was just an x. I do not want to divide by whatever I'm trying to solve for. You hear that? That's pretty important, okay? Because we had a little study session in study hall yesterday, and that was one of the steps that somebody suggested. Hey, let's just divide by an x. That would get rid of one of the x's, all right? But we don't want to do that because it'll get rid of one of our possible solutions, all right? So we don't want to do that. So what we want to do is, if you look at the title of the lesson, by factoring, so we want to factor some stuff out. But let's make it look semi-quadratic, okay? Remember we had it equal to 0. So I like to have things equal to 0. So I think that's what we're going to do. Yep, we're going to do that on both of these examples. So if I want something equal to 0, what am I going to do here? We'll keep the x to the 4th here. What am I going to do with this 4x squared? Just subtract it, move it to the other side. That's right. And then I'll have it equal to 0. So let's do that. Whoops. So it's x to the 4th minus 4x squared equals 0. All right, because that's what we're basically doing in this whole lesson is setting things equal to 0 and then solving for whatever letter they want you to solve for. Now again, it says solve by factoring, so now we have this set up. Is there a common factor? Is there a common factor with both of these things? Yeah, what's in common? Trey, you shook your head. X squared, that's right. There's an x squared in both of these. We've talked about factoring before. We've done it a long time ago. So let's factor out an x squared. So we'll factor out an x squared, and let's see what's left over. When we factor it out, what are we really doing? We're dividing it out, aren't we? So it's x squared divided by x to the 4th divided by x squared. So what do we have here then? X squared, good. Minus, now we take this and we divide it by this. So you're left with a 4. The x squared over x squared just goes to 1, so that's it. You could always double check by distributing, right? X squared times x squared is x to the 4th, minus x squared times 4 is 4x squared, so we're good. We factored it correctly. But it looks like we got some more factoring to do, don't we? Do you see something that you could factor here? Yeah, that x squared minus 4. Do you see that? What kind of factoring is that? This will really test you. Difference of two squares, very good. Okay, this is a difference of two squares. So this is a factoring we've done quite a while ago. It's one of our special factorings. So aren't you glad you learned that before you got to this problem? Sure. Yeah, they know what they're doing, okay? They always prepare you, okay? It's a building block. It's steps. You learn a little bit, then you apply it, then you apply it again, you apply it again. That's what we're doing here. All right, so let's factor a difference of two squares. Difference of two squares is one of our easiest ones to factor, I think. So you're going to have a plus and a minus. You're going to have an x here and an x here. Remember, difference of two squares, the outside and the inside actually add up to 0. So all we got to do is figure out what times what is 4, and they're going to be the same exact number because it's a square, and it's 2 and 2. Simple. Yeah? Okay, you recognize that, don't you? So you need to recognize that, all right? Something we've done before in the past that we got to make sure we know how to do. All right. Now, we're kind of left with what we did the last couple days, right? We have things that are multiplied together and they equal 0. So what are we going to do with each of these 3 terms? We're going to set them equal to 0. Very good. So we set them equal to 0. So we set x squared equal to 0. we said x plus 2 equal to 0, and we said x minus 2 equal to 0. Right? That's not new. Really, is there anything in here that's been new? Nothing, right? Just probably the hardest part is just realizing, take this original problem and turn it into this. To tell you the truth, that's probably the hardest part of this whole problem. And that wasn't even that hard, was it? No. So now we can solve for x. So what's x going to be right here? What squared is equal to 0? Well, 0 squared, right? Or I could do what? Square root both sides. What's the square root of 0? It's 0. We good? What about this? That's easy. It's -2, and this, +2. And that's it. That's our answers. Do we necessarily have to check this to make sure all those answers are right? No, because remember, remember, only if you square both, only if you square both sides do you have to check, all right? Did we square both sides here? No, we didn't. So you don't have to worry about it. You can be confident that circling those answers are going to give you the right answer, okay? You could always plug them back in to see if they work, okay, if you're not sure about it, but that is the correct answers, okay? We got one more to do. Example 8. And again, it says to solve. All of these say to solve. We got x cubed minus x squared minus 4x plus 4 equals 0. All right. This isn't like one of our quadratics, is it? No, it's not. It's locked. So this is not one of our quadratics. This is not just x squared, ax squared plus bx plus c equals 0. Right there. Thank you. So what in the world we're going to do here? We already got a set equal to 0. I mean, can I factor that whole thing right there? No, I have no idea. There's no common factor, right? You got an x here, and an x here, but you don't have it here. So you can't factor out a common factor. You have a 4 and a 4, but you don't have it here. So I'm kind of stuck. What do you think? But I do have this. Watch. I do have an x squared in common with these two right here, don't I? And what do I have in common with these two right here? A 4. So maybe if we group them together, right, do two separate things, maybe we could factor out an x squared from this and then just a 4 from this. That's called grouping. Do you remember factor by grouping? Again, I sound like a broken record. You probably don't even know what that means, do you? A broken record. Why is that a broken record? Have you ever listened to a record that was broken and it skips, right? It goes, it keeps going back, right? It repeats the same thing. So we're going to get to a point when I say broken record that people are going to have no idea what I'm talking about, but that's what it is. Anybody ever listen to a record? Have you? Who's never actually listened to a record, a vinyl record that goes in a circle? It's more than that. Okay, yeah. And that's fine. All right, you guys are young. There's no reason to. But now vinyl's kind of coming out now, isn't it? Like a lot of groups are, putting their stuff out on vinyl. That's what I grew up listening to. All right, enough of that. Let's group this together. So what I'm going to do is I'm going to group x cubed minus x squared. Now this is where you got to really be careful, especially when you have a minus right here. Okay, I'm going to put a minus and I'm going to put a parentheses. But remember, this negative has to be distributed through this. So whatever's inside here should equal -4x plus 4. So you got to be careful. So what do you think I'm going to put in the first spot in my parentheses? 4x, right? Because that's minus 4x, right? You would think you'd put a plus 4 here, but do you? Why not? Haley, you shook your head. Why don't you put a plus 4 here? Because that would give you what? It would give you a minus 4. Is this minus 4? No. So what are we going to have to put right here? A minus. That's right. You see, that's the toughest part of this problem right there. I mean, it's not tough, but sometimes people miss it. All right? It's very important that you put a minus here because when you distribute this negative, this has to be this. So it's got to be -4x and then minus a negative, which is plus 4. You with me on that? That's the part that kids get hung up on, or not just kids, but any math student would get hung up on this. So you got to make sure when you distribute this through, it should equal what we started with, and that will make this equal. So don't make this a plus right here. Don't just stick a minus and then a parentheses, because that minus has to be distributed through that parentheses. All right, now why in the world did we just do this? Why do we make it like this? Because look, I can factor this thing now, and I can factor this right now. You see it? That's factoring by grouping. I group them together. So I'm going to do two factorings. So let's factor just this parentheses right here. We kind of did this in the last one. Okay, what's in common with both of these? An x squared. So let's figure out, if we pull out an x squared from both of these, what do we get? Well, we get an x minus what? If I take an x squared out of this, what am I left with? A 1, that's right. See that? Again, double check it, okay? Distribute it. X squared times x is x cubed minus x squared times 1 is x squared, so that works. Put a minus here. Now, what's in common with these two right here? A 4, so we factor out a 4. Let's find out what's left over. Divide this by a 4, we're left with x. Divide this by a 4, we're left with a 1. Again, let's make sure it works. Okay, that's a 4x, and that's a minus 1. We good with that? Equals 0. Now, they rigged this thing, didn't they? Because look, now you have something in common with both of these terms. Okay, and x minus 1 is in common with both of these. So we've done two factorings already, and now we're going to do another factoring. All right, so it's just a greatest common factor. Okay, what's in common with this and this? An x minus 1 is. So I'm going to factor out an x minus 1. Again, broken record, we've done that before. Okay, we have. We've done every step in here we have done before. We just haven't put it all together to solve for x. All right, we've done it with factoring. They taught you how to factor it, but in the past, they didn't have it equal to 0, so you couldn't solve for x. So we're putting all that factoring practice into play here. So if we pull out an x minus 1 from this, what are we left with? We're left with an x squared. Put a minus because of this right here. If we pull out an x minus 1 from this, what are we left with? 4. That equals 0. So how many factorings have we done so far? We've done 3, haven't we? Well, guess what? We're not done factoring, are we? Do you see it? Okay, we got to factor one more time. And again, just like on example 7, we have a difference of 2 squares. And it's exactly the same number, isn't it? Remember we had on the last example, x squared minus 4. So now we got to factor that as well. So keep factoring until it won't factor anymore. So this is a difference of 2 squares. We already did this in the other example, so it's going to be x plus 2, x minus 2. Let's think ahead a little bit. Instead of writing x minus 1 equals 0, x plus 2 equals 0, x minus 2 equals 0, could we just go from here right to our answer? I think we should be able to, don't you? So if I put x minus 1 equals 0, what's x going to be? 1. That's right. And does it work? Sure, because if I put a 1 in for this, 1 minus 1 is 0. 0 times any of this, I don't care what this comes out to be, 0 times anything is what? 0. So it works, doesn't it? What about this? What am I going to put in for this to make it equal to 0? A negative 2. Very good. And then what am I going to put in for here? Positive 2. Now you get it. So if you wanted to go right from here to here, instead of putting x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0, if you wanted to do that, I'm perfectly fine with that. All right, you should be able to actually go from here to here. And that's our answer right there. So we actually get 3 answers. It's not so bad, is it? It's really nothing new. Okay, all the factoring we've done, that exact kind of factoring. Really, the only thing different about this compared to what we did in the past was that it was equal to 0. We set them equal to 0 when we solve for x. Before, on quizzes and tests, it just said factor this. That's all it said. All right. But now we're actually solving for x. We're finding what x is equal to. Well, that wasn't so bad. A pretty easy lesson today, wasn't it? Yeah. Usually the ones at the end of the section, a little bit harder. But I think the middle, I think section 2 is probably the hardest out of everything from 1-4. I don't know. That's just my opinion. All right. Well, let's take a look at what our homework is. You should know what it is already because I gave you a sheet on Monday. So this is part 3. And then it's page 123. And we're doing 73 to 87. And it says on the sheet that I gave you on Monday, it says all, but what have I told you the last couple days? I changed it back to odds. Okay, so if you look at the paper I gave you on Monday, it does say all, but I changed it. I was a little bit nicer. All right, I decided just to give you the odds on this. Okay, that's it.